All right, I've turned this on, so hopefully anybody at the back can hear. So, howdy folks. Thank you for coming to the session today. I know it's getting towards the end of the day and probably getting a bit tired, ready to take a nap and see what those, who won those prizes from the actual booths out there. I'm going to talk to you today about a topic which I think is a bit of a point of conflict with developers, and in particular app developers. Should you write UI tests for your apps? But before I get into it, I just want to give you a quick overview of who I am, just in case you're wondering who this guy is who's been crawling out the woodwork. So my name's James Croft. I'm a Microsoft MVP in Windows app development, and I'm also a principal developer at Razer in Sheffield. I've been developing desktop, mobile, web apps for probably 10 years now. But I have a specialized focus in DevOps, so improving project delivery from requirements all the way through to getting your software out to your clients. You can hit me up on socials. I'm usually on Twitter, and you can also check out my GitHub. During this session today, there's a demo, and that demo will be on my GitHub, in case you want to take a look at it. If you have any questions, feel free to just throw them out, but save them to the end if you're not one for shouting up. So earlier in this year, I think it was, everything's just blurring into one now. I was curious to see if app developers were writing UI tests. So it was a really simple question that I threw out on Twitter. Do you write UI tests for the apps that you build? 3 responses: yes, no, and what's a UI test? And I bet you all know what the most common answer was. It was, in fact, no. So I was curious, and I put it in the Twitter poll here, asking people, if you don't do it, why? What is your sort of commentary as to why you don't write a UI test? So let's have a look at some of those responses. So the first one I got was missing an I should option. Half the people who have commented on this poll are probably lying, and the other half just are hitting no and cringing. This individual is ambitious. They want to write UI tests, but maybe they don't have the time, cost. There are other factors that come into play with writing UI tests. The second one on here, if this poll was up a couple of years ago, they would have been on the I should fence, but now they've incorporated that into their daily routine, and they feel that in the past, it's taken them a long time to write UI tests, and that might resonate with some people. It does take a while to write a UI test. When you compare it to writing your integration tests for your apps, for your APIs. Sorry. Another one on here. This person's definitely writing them. They're using Uno platform, which is a cross-platform application builder, and they're using Uno's UI test. And they're also building Xamarin apps, some cross-platform Xamarin apps, and they're using Xamarin Ui Test, which is a framework, and then Selenium, which is another UI testing framework. And this final answer, I think, is probably the most common response that I had. They answered no, because they don't know how. They don't know how to write UI tests effectively. So I wonder how many of these just a handful of the comments, I wonder how many of these actually resonate with you today. Before we jump into showing you how to write UI tests, let's take a look at what a UI test actually is. And it's not something that you get your users to do once you've shipped your app. So at a high level, these are the common types of software tests that you might write. I've put this as a pyramid so you can sort of see that structure. And at the bottom, we've got unit tests. Now, unit tests are testing a specific function within your application. It might be a method, it might be a class, but these are very discrete functions that might be, maybe you've created an abstraction for your storage for your application. So you're just testing that a file is being saved to disk. We don't care that, you know, an application domain function like uploading an image for your profile is being saved to disk. All we care about is that it's saving to disk. These types of tests, you're going to write lots of them, but they're only going to be very small. So that's why we've got that at the bottom of this pyramid. Lots of tests. Then we move up. We've got integration tests. They can sometimes go by other names. I call them integration tests. And essentially, these are that next layer. You're testing your APIs, your back-end code, and it might also encapsulate some of those tests that you might write as a unit test. You know, that example that I gave before. Storage, you know, you're uploading a file as a profile image, and you're verifying that profile image is being uploaded to your database. You're going to go and check the database to make sure that file's there, and then do your assertions. So it's a bit more than a unit test, but you're going to write fewer of these because you're testing more. You know, you've got breadth of code coverage. And then right at the top, we have UI tests. Now, you might see this pyramid in different ways. You might think that there's more to it. This is just an example that I've put together. So UI tests, you know, in their simplest form, a UI test is about checking that your application handles user actions, so button clicks, typing on a keyboard, or, you know, some other type of input. And then the second is verifying that visual elements, like a button or like a text field or an image, are displayed correctly in the UI, and that they work as intended. Now, while a UI test doesn't verify that your image that you uploaded for your profile picture has gone to the database, what it can do is it can click that button to upload the image. It can select your image. And then when it uploads it visually, you know, maybe in your application, you're going to show the user that that image has been uploaded, you know, actually visually show it to them. So while your test won't test that it's going to the database, what it can do is verify that it's done something behind the scenes with that visual indicator. You know, your users don't care that you've uploaded an image and it's been stored in a database. All they care about is that that image is there and is available to them across the application. So because we are at the top of this pyramid, the UI tests that you write you'll just naturally write less, because you're testing more than just that API integration or that unit test. You know, you're testing an interaction right from the beginning to the end and all the way back. You know, with an API and integration test, for example, you know, you might be testing that a post works, but in a UI test, you might be, without knowing, testing more than that. You know, that the post has worked, that the get has returned as well. So you are testing more. Now, each of these types of tests that I've talked about are all important in their own right. What I'm not saying is that UI tests are the only tests that you should write. They all play a part in what you are, what you are testing. You know, there are maybe examples where writing a functional integration test is better than writing a UI test. But for any interaction that you have in your application, you should write some kind of UI test, because that is where your users use your application. You know, they do not care that your API is working correctly, because you could have the best API in the world with a shoddy application that's not able to interact with it properly. So, UI tests itself come in multiple flavors, and I'm going to talk about both, the ones that I've captured in this talk, and they are manual and automated UI tests. You know, when I talk about UI testing, I think a lot of people immediately go to the automated side, writing a UI test. You know, something that your machine runs and clicks. But in reality, manual UI testing is also a form of UI testing. This is where a human, myself, might launch that application on my machine and start clicking around. I might test that when I click on the button that it launches the file picker, I can pick a file, and then that gets uploaded and I can visually see, there's that image on the screen. But this type of testing is prone to human error. For example, I might accidentally click a button twice, and that might cause a problem with the application. Now, while that's a valid bug, it's not what I intended to do with the app. So, that sort of encompasses that sort of human error aspect of manual UI testing. There's also a time sink in manual UI testing. A tester, a person has to create test cases. They have to make sure that the application is in the right state themselves, perform the UI test, and then verify it. And anything that comes out the back of that. And that can take a long time. Now, as an application grows, those tests become a bit more difficult to run. You might have some more complex scenarios that you're building. So manual testers might not want to spend the time clicking around your application to get it into the right state. And you get that sort of, feedback from them that this is taking too long. There's got to be a better way of doing that. And that's where automated tests come in handy. If there's very complex scenarios that your manual UI testers feel take a long time to run. So what I say on this is manual UI testing works really well for visual feedback and usability. An automated UI test won't be able to check that a button's misaligned. Now, you probably could do some calculations yourself in your UI test, your automated UI test, to verify that a button is in the top left or top right corner of the screen. But that's much faster for a manual tester to go in and check. So there is a benefit to doing manual UI testing. But one of the things that I had drummed into me when I was sort of learning sort of back-end development code was, if it can be automated, automate it. So the other flip side to this, automated UI testing. The first thing I want to point out about automated UI testing is how resilient they are. I can write a test and run it, and it will be reliable. Every single time that automated UI test runs, it will return the same result. Now, the UI might have changed and might have broken something, but the test itself is doing the same thing every time because every step's automated. So we don't have that human error. We know that we're only going to click that button once. In my opinion, coming from the manual UI testing side, automated UI tests are probably the best type of test that you can do for UI testing. If you know, you do sort of already know this anyway around automated testing when you write your API tests. An API test obviously tests that functional aspect of your application from the back-end side. So why would you not do the same thing from the UI? Also allows you to run those tests quickly. A manual tester might spend a good half a day testing a part of your application, whereas a UI test might only take a couple of minutes. And one thing that I pointed out to some of our manual testers at Razor is that you also don't get that feedback from them that they don't want to run those tests because they take too long. So your computer's not going to tell you, I'm not going to run those tests today. Also allows you to pivot your manual testers. Manual testers traditionally come from a non-technical background. They are used to sitting behind a computer and performing interactions with your applications. But what you can do is pivot your manual testers to write these automated UI tests for you and incorporate them as part of your development team. It gives them the opportunities to learn and grow and potentially even consider a role in software development. And finally, automated testing enables your team to receive feedback a lot faster. You can run these UI tests on an automated build and get a response immediately once it's completed. You're not waiting for a tester to write down everything that they've done, upload it somewhere so that you can see what needs changing. And you can even automate bugs being created depending on what system you use, Jira or DevOps, to create the issues out the back of UI tests failing. So it gives your team that immediate feedback that they need. Also gives them some insight into the quality of the application. If I've written 100 UI tests and, I don't know, say the image uploading for the profile is starting to fail and everything within the settings area of your application is failing, that potentially something has broken in that area, and you can immediately go and fix it and see those UI tests then run again and give you the result that you're looking for. Automated UI tests, all of this combined allows you to improve the cycle of shipping your software. And it creates that minimum baseline of quality for your application. And as I said before, manual testing is really useful for sort of that visual aspect, being able to see that things are in the right place. Automated UI testing doesn't really work very well for that, and that's why you have these two work together. So what are some of the challenges that people face with UI testing, and why are so few people writing UI tests? So what I'm going to show you next are a few comments that I've also received from teams that I've worked with, teams in the past, as well as so I do a bit of consultancy in my job. Some of the comments I get from other testing teams, and some of these might also resonate with you. So here's one: my UI changes too often. And that's understandable. Applications grow, they evolve over time. And it can often feel like a wasted effort to put in that upfront UI test. Why should you spend the time writing a UI test when you know that the UI is going to change? And I've worked on so many applications where they've made a major overhaul to the UI, completely changed it without revving that major version of your application. So there are things that you can put in place to stop this from happening. Both in the UI test itself and your DevOps lifecycle, the way that you actually deliver software. And I'll cover some of those in a sec. There's another that comes up often: my UI tests take forever to run. Again, a very fair point. I think when you consider the time that it takes to run these as manual tests, people might not complain as much. But it is a fair point. UI tests run on physical hardware. They're running on your phone, they're running on your laptop, they're running on a hosted agent in the cloud. And you've got other things to contend with: network requests, the specs of the device itself. Are you running this on a low-end Android device or a high-end VM in Azure? I've worked on a project before I joined Razer that took an hour to run the UI tests, but that's an hour compared to the days that it might have taken for a manual tester to run. And I'm sure that there's people out there who've got UI tests that run for a lot longer. And there are ways to solve it. They don't solve the issue around the UI tests themselves taking forever, but they do solve the problem of how it impacts the development team or your build teams. And again, I'll cover some of those in a sec. This one comes up often. The team didn't include IDs on inputs. Now, I don't know if anybody's written UI tests before, but the way that UI tests work is that they have to scan your application to find some identifier, whether that is a unique ID or with a web application, if it's a class name, for example, to be able to actually find that element and interact with it. And in most cases, it's usually an ID. With a web application, this is your ID. In a Xamarin app, it's an ID on the element. This comment usually comes from teams that have a manual tester doing this, writing the UI tests. So they're not involved in the day-to-day code development of the application. And like the UI changing too often comment, there are things that we can put in place to help these members of the team that feel that that IDs and things aren't being included in their applications. And then finally on here, writing UI tests takes too long, and inevitably they become unmaintainable. And I agree with it, even from personal experience. When I started writing UI tests myself, they do take a long time to write compared to integration tests, and they do often become unmaintainable. When you compare all of these challenges together, you've got that problem around the UI changing too often. So when the UI changes, your tests will inevitably break. But there are ways that you can solve this in your UI, the way that you structure your UI tests, so that you don't have this problem, or at least the problem is a bit more diminished than you're having to scrap everything and rewrite your tests again. Why would you invest in writing UI tests if it's going to take a whole day? That again, you're comparing it to the manual UI testing. If it's going to take longer to write the UI tests, is it really worth it? I mean, yes, potentially. You've got other things to contend with. What if that manual tester has to run those tests again and again? What if there's a breaking change in your application? There's a regression test that needs to happen. They're going to test the entire application end to end. When you've got those UI tests in place, that solves that problem. They don't have to do it again because you've got the automation in there. I've also heard this comment come from the clients that I've worked with. We're building applications for clients. Why would they spend money on you writing a UI test when they could get another feature for the same price? That feature is going to take priority for your clients. They don't want you to spend a whole day writing UI tests. These things should be short, sweet, and just work. And behind the scenes, you not have to make too many changes if something changes in your application. We know that skipping on tests from the API side exposes your application to potential issues. So why would you not write UI tests? So now we're going to take a look at writing UI tests while we ponder on those challenges. And the first thing I'm going to do is just walk through a couple of frameworks. By no means this is not an extensive list of frameworks. There are a lot more out there, but these are just a few of the more popular UI frameworks that are available, and some that I've just thrown in as examples. So these are just logos. I'll run through them row left to right, starting with Selenium. I'll start with Selenium because this one's probably the most popular choice for writing UI tests. It's an automated UI testing framework for web applications, and it's been around for God knows how long. I think it's early 2000s. And it's evolved over time. As browser technologies have changed, Selenium has grown with it. And it's an open source technology, so you can go and contribute to Selenium. They do regularly keep this up to date with changes in browsers, so when a new browser version comes out, Selenium makes sure that any features that are available in that browser, if there's anything new added, is available within Selenium. And it comes with multiple language support. So if your team's used to building web apps and they write in JavaScript, you can write your Selenium tests in JavaScript. If you're like me, you write Xamarin applications or Windows applications in C#, you can use C#. So you can leverage those existing skills of your team to write UI tests. You can bring all of those skills in together. Next up on this list, we've got Appium. Now, name sounds familiar. It's a framework that's built on top of Selenium. But this one's specifically for writing tests for native applications. So for Xamarin, for Windows and for Mac OS, for mobile, for Android and iOS. And you can use it for writing UI tests for applications that are built with Xamarin, cross-platform applications, Uno, for example. Because it's built on top of Selenium, you get all of that additional functionality that you get with Selenium on top of it, multiple language support. So again, you're bringing everything together, your team work as one. And if you're writing cross-platform applications, it's really easy to write a single UI test with Appium, because it's built on top of Selenium, that runs on Windows, Mac, and the web, because it's all built into Selenium. Next on the list is Lagerity. Now this is a framework that's built both on top of Selenium and Appium. And you'll find this quite often with UI testing frameworks, is they are usually built on top of Selenium. And the reason being because it is so popular. Now, Lagerity is a framework for, again, that entire range of devices, but it's specifically built with C# and .NET. It doesn't have a JavaScript support, unfortunately. But it simplifies the development. Now, there are some things that are within that framework, like design patterns, that allow you to quickly write your UI tests. Appium and Selenium out the box are just a UI testing framework. They don't do anything else for you. You have to do all the legwork. So Lagerity takes those frameworks and makes it simpler to write UI tests. And in the demo that I'll give shortly, I'll show you how Lagerity works together with Appium and Selenium to write UI tests that are maintainable. On the next row, we've got another one that's built on top of Selenium. So this in the bottom left corner is called Protractor. Now, I don't know if anybody writes AngularJS apps or Angular apps, but Protractor is built specifically for those scenarios. You know, if you write an application out the box, what Protractor does that's built on top of the other, on top of Selenium and Appium, is that if you write an AngularJS application and you use Angular syntax, Protractor allows you to find elements within your UI based on that same syntax. So if you're used to writing an Angular app, writing the UI test is a lot easier. So, you know, say for example, you had a UI element which was a list, you know, and you're looping through the list to generate a UI. What you can do with Protractor is find that list query. So what you've created, and what it will do is it will give you back a list of items that you can then interact with. So you don't have to worry about all of the, you know, searching your UI to find each UI element itself. Also, next on the list is Smart Bear Test Complete. Now this is a bit of a weird one. It allows you to write UI tests with no development experience. It's like a full IDE. It's got integrations with Azure DevOps, via CIs, Jenkins. But because it isn't all in one and it's, you know, it's sort of its own entity, unfortunately it's not an open source or free piece of software. It's a paid solution. But it gives your team, especially if you're working in a team with manual testers that don't write code, they don't understand code, or, you know, it's not something that they're interested in jumping into, allows them to write UI tests with like a drag and drop click style IDE. Also, it allows you to run Selenium tests. So if you do already have a suite of UI tests, you know, maybe you had a development team that was writing them, but now you don't. It allows you to bring those UI tests across and then build the additional ones in that sort of low code, no code sort of IDE. And then finally on here, we've got Xamarin Ui Test. I don't know if anybody in the room is a Xamarin developer or Xamarin Forms developer, but Xamarin Ui Test is purpose-built for those style of applications. Now, Xamarin Forms, because it's a cross-platform solution, the way that Xamarin Forms works is you write one UI and it just runs on iOS and Android in the same way. The way that you create your XAML layouts is exactly the same for both. So it's designed in a way that allows you to write one UI test that runs on both platforms without, you know, any additional changes. You know, you don't have to write two tests to run on two different platforms. Now, Xamarin apps compile down to native code. So you can use Xamarin Ui Test to test Android applications or iOS applications. But what I would say is there are better options than Xamarin Ui Test for those scenarios. So if you're only writing an Android app or you're only writing an iOS application, I'd suggest taking a look at Appium. Like I say, these are just a handful. There are plenty out there, and I've got a link at the end which will you'll find some more frameworks if there's something in here that's not right for you. But what I would say is that Selenium itself is probably the most common one, and it's really easy to use as well. So let's take a look at Selenium in action, specifically Appium. Lagerity. So this is going to be a bit odd now because I'm going to have to keep turning to face the screen because I can't see it on mine. So this is just an application that I built. It's a demo application, and like I said at the beginning, this demo is will be available on GitHub, so you can go and take a look at how these UI tests are written and maybe have a play with it yourself. It's a simple to-do list app. It has some functions. I can add a task list, I can edit a task list, I can delete them, and within a task list, I can create tasks. And again, there's functions of a task as well. I can complete them, I can edit them, and I can delete them as well. There are some UI bits that we can see in here, like the due date, and these are all parts of a UI. And as you can see as well, we've got repeated patterns here. Each one of those tasks is the same thing. So I can click around this application and I can run my manual test myself. I might have a test case for when I add a new task, it should add to the task list. And I can do that myself. I can click through, I can add a task and visually see that it's working. Or I could write an automated UI test. So this is just the application. What I will do is jump into Rider. So talking about, as I mentioned earlier in the presentation, I said that certain tests, a UI test is not the only test that should be involved in your application. You should incorporate some of those other types of tests, like a functional test. So you'll see in this application, this solution, I've got both functional tests and I've got my UI tests as well. So the functional tests here, I'm just testing scenarios that, because this is just a noddy application, the UI tests themselves, the functional tests are testing the login, the authentication piece, because I don't really need to test that in a UI test because I'm going to have to log in every single time. So what I do instead is I create these functional tests that test the API. So I can create a login and validate that that login credential is spot on. I can also check that if I input the wrong details, it rejects that, that API request. So this is just a quick example, and it's not really relevant, but of how you might incorporate functional tests as well as UI tests. So on the left here, what you might have seen, I've lost my cursor, is the structure for my UI tests. And there's quite a few elements to this, and I'll run through each individual. So, to make my UI tests the same, every single one run the same, using Lagerity, what I've got in here is this app manager. It comes out of the box with Lagerity, allows me to create an application instance in a way. Under the hood, it's just using the WebDriver that comes with Selenium or Appium. But in this example, I've constructed a test fixture that is testing my application on both Chrome and the Edge version of the Chromium version of Edge as well. So what I can do with this is create consistent UI tests that run on multiple browsers. As I scroll down as well, as I mentioned before, logging into an application is the same across every UI test. Because a UI test runs as a fresh instance every time, I need to be able to get the application into a state where it can start running a test. I don't need to test login every time, but I do need a way of logging in. So in this application that has authentication, what you'll see here is I've got this is just a bog standard, I guess, setup for any type of test. This is using NUnit under the hood. At the top, we've got a setup method, which starts the application. It's going to get some config. It's going to sort out the app settings, start the app, and then log in, because, like I say, you don't need to worry about login. I've then got to tear down. That's going to stop the app manager. What that'll do under the hood is it stops the Selenium driver. But right at the bottom here, we've got that login function. And what you'll see as part of this test fixture is a concept that I'm going to talk about next, which is the page object pattern. Now, when you write a test, when you write an API test, as I was showing you before, you call within the test itself, the test structure, you set some things up, you might arrange it, you then call an API directly, and you might construct a HTTP client, for example, to call that API. You make the request, you assert the result. But that can get quite unwieldy with a UI test, because there's a lot more involved. We've got to query UI elements, we've got to find the right thing. So the point of the page object pattern is to abstract some of that information. So we take a layer out of the UI tests, so the tests themselves actually only interact with a page object. And the page object, if I jump into it, so the home page is the example I'm going to use here, is where we start incorporating those queries. Now, this applies to any UI testing framework, but obviously here I'm showing it using Selenium. But in Selenium, it uses this thing called a by query, and that allows you to look for an item, like I said before, like searching for an element by an ID. So in here, we've got a few concepts around what a page does. So this home page is a physical, I guess if I pull these up side by side, it might give a better representation. This is the home page of my app. Let me just close this down. And on the right here, this is a representation of what this page can do and what's on this page as well. At the top, you'll see the task lists sidebar, and that's finding that by an ID. And that's this bit on the left here. The tasks sidebar is the bit on the right, and it's finding that element. They are elements of this page. So I've incorporated that into the page object. Then there are actions that I can have on this home page. So add in new task list, for example. You see the button at the top there. If I press that, it'll show a modal dialog, and then I can add a task list to this sidebar. So that's an action that I can perform on this page. So I incorporate that into my page object. Edit task list, delete task list, add in tasks to a task list, selecting a task. These are all functions of this page. So I incorporate them as actions within the page object. Now, one of the things you might notice on the page object is that for each one of these actions, I'm returning the instance of the page. And what this allows me to do in my UI tests is chain them together. You know, I don't have to keep calling page.blah, page.blah. What I can do is do, you know, as that example that I was saying before around potentially add in a task to a task list, I can do page.select task list .add task and then verify that the task exists in the list. So by creating that structure, we're abstracting away the selections, and then we can write UI tests which are functional. What this allows us to do is ensure that we don't ever have to touch the test itself, because the functional test will never change. The way that you add a task to a task list might, but adding a task to a task list is a function of your application. That will not change. So let's bring this back across. Actually, I'll keep this up on the side here. At the top of this page object, you'll see that I'm actually not interacting with what is part of Selenium. It does get a bit more Selenium specific, but it can be applied to any UI testing framework. As well as the page object, I've also got these element wrappers. So what you're seeing in this page object, this task list sidebar, is not a part of any of those frameworks. It's something that I've written. And that is a wrapper around a specific UI element, a UI component that I've created. So the task list sidebar, this bit here, I've abstracted that again. You know, I'm taking more of that code away, and it allows me to interact with things that may or may not have IDs. So if I actually go into this task list sidebar, what you'll see in this test is that there are certain elements of the UI which don't have IDs. The tasks themselves, the task lists, don't have IDs. Why would they? Each one of these is added dynamically in my application. I can't create an ID for them. I mean, I guess I could, but it wouldn't be the same every time. So you'd never be able to write a consistent UI test. So in this test, we're looking for all web elements that have a specific class name, a task list item, and that returns each item within that list. And again, when you look at that task list selector as well, we've gone a little bit further, a task list summary. And a task list summary is that individual, what's highlighted as my tasks, is that individual component. So what we're doing is we're mimicking what's within the application, within our UI test. So if we ever make a change, if we, remove the edit button, I don't have to go and update every single test. I can come into this task list summary, just remove the edit button. I might need to go and update my tests. But I don't have to specifically change anything within that test itself. I'll say, for example, the class name changes. Designer comes in and they decide that task list item edit is a bit too wordy for a class name, and they change that. I don't have to change it in every UI test because I can come here and change it in this one area, and all of my UI tests start passing again. And then we've got the tests themselves. So I can expand this back up now. So then we've got the tests. So this is just an example of these Selenium or UI tests that are written on top of Lagerity. And I'm writing these as functional tests. And the reason I do this is because I don't want to write a lot of them. You want to keep these as broad as possible, testing as much as you can. So in this example, I had a feature requirement from a client that I should be able to add tasks to a task list. So I create my UI test when adding tasks. And then inside here, I have each of the tests that I can perform to check that something is happening. So in this example, one of the scenarios for adding a task is that it should add it. Pretty self-explanatory. But then I've got another test in here that ensures that if I didn't include the name of the task list itself, it won't create it. And you'll see in here that we've got some assertions that are just validating some parts of the UI. Now, when you look at how this UI test has been constructed, if we had to delve into each one of these pages, each one of these interactions, and each element, this UI test could get very long. But what you see in here is something that's human readable, something that someone can come into this UI test and see what's meant to be happening and ensure that it is valid themselves. So in this example, for not being able to add a task list if it's empty, we create a new home page object and we add a new task list. We give it a task name. We then add new tasks to that task list, but in this test, we've decided that we're going to pass string empty, which means that we're not going to put a value in. So when that happens, the function for adding a task to a task list, although we're telling it not to put anything in, we'll still click save. When we click save, our application validates that that field has been populated, and then we'll show a validation error message. And then, so the assertion is going to find that input and validate that it has this class on it, which verifies that it's in an invalid state. Does that sort of make sense? Essentially, what you're trying to do with this is create that maintainable test structure. The same way that you would, when you're writing your functional API integration tests. So that's just mimicking that. And this is just an example using Selenium, but these concepts can be applied to any UI testing framework. So let me just jump back into the slides. And we'll run through these really quickly. So, UI tests changes too often. UI changes too often. Things that you can solve with this. Organize your workflow. In this example, when I was building this, well, it was just me building it, but as an example, you might have a team that are building your application. Incorporate a testing phase into your DevOps flow. And what this allows you to do is take your functional feature, your user story, dev it, and once that dev is complete, you pass it into the test team. That UI shouldn't change from that point on. You've finished your functional requirement. So your testers can then pick this up, they can write the UI tests, and they won't have that sort of worry that something's breaking. When you do have to implement a breaking change though, make sure that it's with your major releases. Don't change your application's UI while you're building it. Now, this can be difficult when you're starting an application. You know, you're going to rapidly develop something and then you might get to a V1. Now, I'd say on this, obviously, this is just, I guess, a common thing that people should be doing as a team. Communicate, talk to each other. You know, if you're going to change a UI, make sure that your testers know that you're changing it before you hit that sort of V1. But then from that point on, any change in a minor release should not majorly overhaul the UI because, I mean, it's in the name, it's a major release. And on the last point, sort of covering what I've just shown you in the demo, write maintainable UI tests with layers of abstraction. Put those page objects in and reduce the area of change that you need to happen in your UI tests themselves. Tests take too long to run. You know, like I said before, this will happen. You know, you've got those factors to contend with. What I would suggest on this is if you are using a CI to run your UI tests, run them as part of a scheduled nightly trigger. We at Razor tend to run our UI tests on the evening of weekdays or midnight, so Tuesday at midnight through to Saturday on midnight as well. And what that allows us to do is not break our dev flow. You know, I'm not taking up time on my CI builds, you know, the PR requests and commits to main, where my development team need to be writing code and shipping code. Now, obviously, this has an impact. You know, you're not going to be running these every time a change is made, but it gives you a visual indicator. You know, each day you're checking that your UI is not broken. And one of the other things that I'd like to point out on the tests running too long is improve your selectors. So you know those by queries in Selenium or however you write them, which framework you use, and I'll use Selenium as an example. But make those tailored to what you're trying to find. Don't make, you know, if you're trying to find a UI element, don't just search for a div, for example, in your web application. Find that ID, that specific ID, or find that class name. And what that allows you to do, if you're only looking for one element, is it scans your UI and reads from top to bottom. So obviously, the higher up your UI elements are, the easier they're going to be to find. And when you're only selecting one item, as soon as it finds it, it's out. It's not checking the rest of your UI. Inputs without IDs, this is the one where I mentioned that I think it mainly comes from people that aren't involved in the app code. And what I'd say is encourage your team, when you're writing inputs in particular, so a button, a text field, a date picker, whatever, make sure you put an ID on it. It makes sense to. These are, in your UI tests, these are the things that will be interacted with. So an ID on any input. What I'm not saying is put an ID on every single element in your UI though. But I'd also say foster an environment, you know, that empowers your QA manual testers to be able to dive into the app code and make those changes themselves. You know, all they're doing is adding an ID. It could break your application. It's unlikely to though. You know, if you need to add an ID to an input field, a tester should be able to go in, make that change, make a PR, contribute to the team, and ultimately not block themselves. And then finally on here, and this is around that, I've thrown it up in the screenshot here. When there isn't an opportunity to use an ID, find another unique identifier. There will be something on your UI which allows you to find a specific element. And in the example with the task list, we can add an ID to the task list itself, but not each item. So we're going to focus on finding that first parent item and then find the children based on another unique attribute, like a class name, for example. The long time to write these tests, you're going to get that through these maintainable design patterns. So write your page objects, keep the tests short, and make them human readable. Implement element wrappers. I would definitely recommend doing it. It's an extra abstraction. You don't have to. You can write everything within your page object. But the point of the element wrapper is you might create an element that you're going to use across your application. It's not just going to be used in one place. It's not going to be used on the home page. You might have a more complex app. So you might have a card, for example, that you use on one page and then use it on another. By creating that element wrapper, you easily transferring that sort of knowledge into another area of your UI test. You don't have to write it again because the card doesn't change, but it's just in a different context. And then write UI tests for scenarios, for functional scenarios. These are the requirements that your clients, your product owners are asking you to implement within your app. So write those to be for functional. And then, as I said before at the beginning, run manual UI tests just to validate those visuals and the usability of your app. You know, that button's orange, but it should be red. You know, it's not a good use of automated UI tests. So that's just, I guess, a small taster as to what UI tests are and how you can write them. And I do honestly believe that you should write UI tests because it does improve the code coverage where it's most needed. Your users use your application, they do not use your API. If you've got a shoddy app, your users are going to move away and maybe find an alternative. It doesn't matter that your API is fully tested and code coverage is 100% if your application falls at the first hurdle. I think I'm probably running a little bit over, but I'll close off real quick. So the links on here, obviously, I didn't want to put the web links on because they were God knows how long, but there are some really useful links on here, and I will share the slides after if you want to click through to any of these. But all of these are also on this web page that I've got at the bottom here. So feel free to take a snapshot of this or scan the QR code and bookmark the page. It's a GitHub repository that I'm starting to maintain around different concepts, different articles that I like, articles that I've written as well around how to write UI tests and how to effectively build maintainable UI tests. And you'll find as well links to all of those frameworks that I've talked about today as well. So if there's something that you're interested in, you can find it. And with that, are there any questions? I realise that nobody asked during, which is fine. Go on.
So in the beginning you said there's obviously unit tests, integration tests, UI tests. So what would you be testing in the UI, in the like unit test and the integration test?
So I would say that when you start writing UI tests and you're starting to write the integration tests, you might not write as many unit tests. But unit tests are useful for testing certain little bits of scenarios. You know, like validating that, okay, it's a good example. You're registering for a website and it's going to send you a code for you to be able to register with that application. But that code's going to get sent in your email. It's not going to get committed to disk. Your integration test can't validate that that's happened. So you might write a unit test to make sure that that token is being created, for example. That's a good scenario. But the API test, the integration test, might be ensuring that the email gets sent. And then that one step further with the UI test, so you might write all three in this, is going to the website, pressing the register button, filling in your email address, making sure that you receive that email. Or, you know, something on the screen says email sent or error sending you because your email is invalid, for example. Does that make sense?
Yeah. So does the integration test include the API running as well?
Yeah. So I guess I sort of didn't cover that.
You don't know about the unit testing.
No, that's fine. So integration tests essentially run your API in a test harness. It will spin up your application, and you don't see it visually like you do with UI tests. But the API integration tests will actually call your API. It'll be running on your machine. Then once it's finished, obviously, it'll close it down. But yes, it's running your physical application. Whereas with your unit test, you might mock things out. So, the email provider, you're not testing that an email is being sent, but maybe your class has a dependency on it. So you'd mock that out in a unit test, but in an integration test, it might be the real thing.
If you had to choose one of those, so like unit test or integration test or UI test, which is the most important one?
If there's something visual, if it's something that's happening within your application, write a UI test for it. There might be a scenario like the sending an email, which actually just happens behind the scenes. So you have to write that integration test because there isn't a UI for it. So that'd be where you'd get your code coverage on that. So it is important to incorporate them all. But if it's anything visual, anything that you can do within your application that you can interact with, and yeah, I'd say write a UI test. One thing quickly, I guess, that I didn't show you, because I'm an idiot, is them running. They don't take very long to run these UI tests, but to be honest, what they do is so fast that you probably won't actually see it do anything other than flash up the screen and then disappear. So this is going to start running those UI tests now on my machine. And it's doing it on this screen, which does not help. Let me stop. I didn't expect that to happen. Let me stop those UI tests running. But just to show you what an automated UI test actually looks like, let me just change this to duplicate. And let me run those tests again. So what this is actually doing is it's spinning up that application. The application's on my machine. And like I said, these run really quickly, so you might catch a glimpse of what's happening. But that login, for example, you're seeing that every time a test runs, it loads the login page. It's logging me in with the same credentials that pass through in settings. But this is only a small application, so what it's doing is actually relatively fast. But this is what an automated UI test actually looks like. This is what it looks like when it's running on your machine or in the cloud. I'll take other questions while this is doing that in the background, but it's just something visual to show you what it's actually doing. When you think about what this is doing, you would have a manual tester running each one of these tests. And this only takes less than 2 minutes to run. But a manual, a human having to sit down on the machine and type in their username and password and click the right button and do the right action, that could take 2 minutes just to get set up for that one UI test. They run a bit slower today, 3 minutes, but yeah. I don't know if there's any other questions. Go on.
So I'm thinking about an application that I'm working on that hasn't got any UI tests on. It's quite a big application, and it take a long time to write UI tests for everything. Are there certain UI elements that lend themselves particularly well to UI tests? So where would you start in a big application in writing tests?
This is one of those scenarios that I think has come up quite a lot with clients that I've worked with where they have already built an application. And what I'd say, and it's the same with API integration tests, start where you are. Start where you are now and backfill any UI tests. If you're going to be implementing a new feature and that feature is quite complex, it might be a good scenario to actually write a UI test for it. And then you start building those things up. You build up the page objects. You don't need everything all at once. Those elements that I was showing you and the interactions, you don't need them all. You just need enough to do your test. But then you might add more and more. And you've already got the framework there to keep building on. So you can retrospectively go back and add more UI tests in. Does that make sense? Yeah. It can be quite difficult, if you don't incorporate it from the beginning to go back, and it's the same for any type of test. But it's definitely worth doing. If you've built an application now and you've not written UI tests, there are some good frameworks out there that allow you to rapidly build them. So I definitely suggest looking at them. Cool. Unless there's anything else, I'll leave you all to it. Thanks for coming.